This week's episode is featuring Purple Cow's BIOACTIVE Supercharger. BIOACTIVE Supercharger is available in a liquid and a soluble powder product that provides your plant with living organisms and trace minerals to produce nutrient-dense vegetables and fruits. Visit stbiologicals.com to learn more about this and other regenerative ag products. Hello, and welcome to the ST Biologicals Soil Speaks podcast. This week, we are going to take a closer look at the next level ag soil test. Let's get started. Soil is a complex of nutrients, microorganisms, plant root exudates, air, and water. The interactions between the different components that make up a teaspoon of soil are intricate and mostly still unknown. We know the most basic aspects of soil. For example, we know optimum potassium levels support flowers, help fruit set, and strengthen plant root growth. Optimum soil health for a strong crop yield isn't the result of one or even a combination of known macro and micronutrients. Soil is the result of the interactions of all the constituent parts, including microbes, water, air, and nutrients. Some soil tests measure the known interactions. We've still got a lot to learn. The soil tests at Next Level Ag incorporate as many soil factors as possible to give you an accurate picture of soil activity. The testing at Next Level Ag gives you data on the chemical, physical, and biological components of your soil. Let's examine these three basic components of the soil test. The chemical components of soil are potassium, nitrogen, phosphorus, calcium, sulfur, and many other macro and micronutrients. An excess or deficit in one can have a profound effect on the others. Soil chemistry is dependent on the pH, the balance of nutrients, and the CEC, cation exchange capacity, of the soil type. Learn more about those factors on our blog. Nutrients are found in numerous chemical forms in soil. Not all of them are available for plant uptake. In most of the United States, the average total potassium content of soils is over 20,000 ppm. However, relatively little of that total potassium is in a form plants can use. Most potassium is tied up in soil minerals. This is true for almost all soil nutrients. Most soil tests, even some used by Next Level Ag, only measure the nutrient forms that improve the health of your crops. If this was all they measured, it would help you achieve good short-term yields, but not improve soil health in the long term. But their tests go a step further in soil analysis. We tend to think of the physical structure of soil as sand, silt, clay, or some combination thereof. Soil type is one component of the physical characteristics of soil, but not the only one. Over time, soil changes its structure. In a conventional agricultural system, soil loses aggregation and becomes dust. Aggregation is part soil type, clay, silt, sand, and part the result of biotic and abiotic actions on those soil particles. A heavy clay can become a clay loam, where organic matter is incorporated into the soil. Soils that can maintain their surface structure, aggregation, are measured on the Next Level Ag Soil Report as VAST, Volumetric Aggregate Stability Test. As soil pores become larger, water infiltrates better. Microbes find it more hospitable when organic matter breaks up heavy clay. When the soil loses some of the water-logging characteristics, the microbial community changes from a mostly anaerobic population to an aerobic one. Earthworms take up residence, and your crops become more productive. Modern agricultural practices have created soils void of microorganisms. Plants that have synthetic nutrients applied to the subsurface in the root zone don't develop relationships with beneficial microorganisms. Crops are dependent on synthetic fertilizer applications for their yield. With farming practices that incorporate no-till or strip-till practices, biological communities have a chance to thrive. As your soil biological diversity grows, the need for synthetic fertilizers decreases, increasing farm profits. The next level ag soil test measures the carbon dioxide burst or level of carbon dioxide in soil. Microbes respire carbon dioxide when decomposing organic matter. When the carbon dioxide level is high, it means there is a lot of microbial activity. Microbial activity fuels nutrient cycling. The nutrients tied up in the soil, unavailable for plant root uptake, are released by microbial activity. So the more diverse the microbial community, the better your plants can access the nutrients in your soil. When the interactions of the chemical, physical, and biological components of soil are in balance, the soil is at a maximum fertility and crops will be the most productive. This type of balance is the goal of a regenerative agricultural system. The WEOC score on a next level ag soil test is the measurement of how much water extractable organic carbon is available. This is the unstable carbon in the soil, and it's a food source for microbiology. The higher the WEOC number, the greater the overall health of your soil. Regenerative ag practices improve all soil metrics and create a resilient ag operation. As extreme weather events and exotic pests become more common, the entire ag ecosystem must be adaptive and functional. Setting up grids for soil testing, creating a year-over-year testing schedule, reading the test results, and then incorporating the recommendations can be overwhelming. But this kind of planning is extremely valuable for developing a future-proof, profitable ag operation. At ST Biologicals, we help farmers and ranchers succeed in converting from conventional to regenerative agricultural practices. Visit us at stbiologicals.com. When soil speaks, we listen. Thanks for listening, and we'll catch you on the next one.